Are you ready? We are about to do something super duper important. We're about to define the trigonometric functions. Okay? There are 6 trigonometric functions. Okay? You have to know them inside and out. You need to commit them to memory. Okay? This and the unit circle. Okay? Absolutely have to know inside and out. Okay? This is the foundation of trig. Okay? So, the trigonometric functions of theta can be expressed as ratios of the sides of a right triangle, and they are defined as follows. Okay? So really quickly, I'm just going to tell you the names or how you pronounce these things because they're funny looking. If you've never taken trig, you notice that you probably don't know what these things are. Okay? So let me just kind of tell you what the names of them are. They're abbreviated. Okay? This first one is sine. Okay? The next one is cosine. The next one is tangent. And then on the right side over here, CSC, this is cosecant. And then SEC is secant. And then the last one, which is cot, that is cotangent. Okay? These are the 6 trigonometric functions. Okay? Again, the foundation of trig. Okay? We can define these guys in terms of a right triangle. Okay? So again, they are defined in terms of the 3 sides, the opposite side of the angle, the adjacent side of the angle, and the hypotenuse. So that's why it's imperative you be able to identify which side of the right triangle is which. Okay, let's go ahead and start with sine. Okay, so again, when you are dealing with a right triangle, you are looking at one of the acute angles, and that is going to be your theta. Okay, to define the sine of that angle, okay, it is defined as the opposite divided by the hypotenuse. Okay, so the opposite side over the hypotenuse. Okay, so if we go back up and we look at our schematic up here, okay, I'll go ahead and erase this. Okay, so here would be your angle theta. Okay, and so you would look at the opposite side. Okay, whatever that length is. Okay, this is length B. Okay, and you would divide that by the hypotenuse, okay, the length of the hypotenuse, okay, which is C. Okay, so your sine, the sine of theta is defined as the opposite side divided by the hypotenuse. Okay, so basically what you're doing is you're making a ratio of 2 sides of the triangle. You just have to know which sides you're working with and which order they go in. Okay, sine is opposite over hypotenuse. Okay, what you should do, okay, you have to know this. You have to commit it to memory. You're going to use it in pre-cal. You're going to use it in calculus. I wouldn't memorize B divided by C. What you need to know is opposite over hypotenuse. Okay, that's how I want you to remember these things. Okay, so the opposite over the hypotenuse, that is the sine of theta. Okay, now something I want to mention to you. Okay, we're not dealing with a specific angle yet. Okay, theta is just a generic acute angle. Okay, if you wrote down the sine, okay, and you told me sine is equal to, you know, the opposite over the hypotenuse. Okay, sine by itself does not make a bit of sense. It is an operator. It does something to an angle. Okay, so when you write down sine, you absolutely have to have the angle right after it, because any of these trig functions, if you just wrote the little code for it down and you didn't write the angle, that doesn't make any sense. It has to be the sine of the angle, or the cosine of the angle, or the tangent of the angle. Okay, it is an operator. It operates on an angle. Okay. All right, so now we can go ahead, and now that we've been introduced to sine, okay, the remaining 5 trig functions are defined in a similar way. It's just one side of the triangle divided by a different side. Okay. All right, so if we go down here, okay, cosine of your angle theta is going to be the adjacent over the hypotenuse. Okay, which again, if you're looking up here, It would be the adjacent over the hypotenuse. You would look at this. Let me erase here. You would take, in this case, you would be looking at the adjacent and the hypotenuse. Okay, so then cosine would be defined as, again, it has to be cosine of the angle. It's going to be the adjacent side, which has length A, divided by the length of the hypotenuse, which is C. Okay. All right, so again, what you need to remember is that cosine is adjacent over hypotenuse. Okay. All right, moving on to tangent. Okay. Tangent is defined in terms of sine and cosine. Okay. The tangent of the angle is the sine divided by the cosine. Okay. So I'm going to come down here and I'm going to show you something. Okay, so it's sine over cosine. So that's one way you can think of tangent, and you should know that. But watch what happens here. If I'm doing sine of theta divided by cosine of theta, okay, that is equal to, well, remember, what did we say sine is? Okay, look up here. Sine is the opposite over the hypotenuse. Okay, so that's really the numerator. It's a fraction itself. And then in the denominator, you have the cosine. Okay, cosine is adjacent over hypotenuse. Okay, so you're really dividing two fractions. So remember, how do you divide fractions? Well, you leave the top fraction alone, you change to multiplication, and you flip the bottom fraction. Okay, and so then what happens here is you have a hypotenuse in the top and the bottom, and those cancel out, and you're left with opposite over adjacent. Okay, so those are two different ways you can think of tangent, and you need to know both of them inside and out. Tangent of an angle, tangent of theta, is sine theta over cosine theta. It's the same thing as the opposite over the adjacent. Okay, all right, moving on to cosecant up here. Cosecant is CSC. Okay, it is defined in terms of sine. Okay, the cosecant of an angle is 1 over the sine of the angle. Okay, so again, you can do some math here. If you're doing 1 over a fraction, it just flips it. Okay, so since you're doing 1 over sine, okay, you would be doing 1 over sine. Sine is the opposite over the hypotenuse. Okay, so like I said, if you do 1 over a fraction, it flips it. Okay, so instead of having opposite over hypotenuse, you would have hypotenuse over opposite. Okay, again, you need to know the two representations of cosecant. It is 1 over sine. It is also the hypotenuse over the opposite. Okay, secant theta. Okay, SEC is secant. It is related to cosine. Okay, it is 1 over the cosine. Okay, so again, you would be doing 1 over the cosine. Cosine is adjacent over hypotenuse. Okay, 1 over the fraction is going to flip the fraction. Okay, so instead of adjacent over hypotenuse, secant is going to be hypotenuse over adjacent. Okay, got to know both. Secant of theta is 1 over the cosine of theta, which is the hypotenuse divided by the adjacent side. Okay, last trig function is cotangent. It's related to tangent. It's defined as 1 over the tangent of theta. Okay, so what you're going to do here, okay, you're doing 1 over tangent. Okay, so tangent of theta is sine theta over cosine theta. Okay, so again, if you have 1 over a fraction, it's just going to flip the fraction, so it's going to become cosine theta over sine theta. Okay, and then you can go a little further with this. Okay, we know that the cosine is the adjacent over the hypotenuse, so that's in the numerator. And then we know that the sine is the opposite over the hypotenuse. Okay, so you've got one fraction divided by another. Okay, so do the division out. This is going to tell us that if you leave the top fraction alone, we'll get adjacent over hypotenuse. Okay, change to multiplication, flip the second fraction. Okay, and then you'll have a hypotenuse in the top, 1 in the bottom. They cancel, and that's going to be, remember, when you multiply fractions, you multiply across the top and across the bottom. That's going to leave you with adjacent over opposite. Okay, so again, you have to know both representations of cotangent, or actually there's 3 here. Okay, cotangent, you can think of it as 1 over tangent, cosine over sine, and adjacent over opposite. Okay, these 6 trig functions, I cannot stress to you how important it is. Okay, you want to commit this to memory. You want to. Absolutely imperative, especially if you're going on to pre-cal or calculus, and actually to get through the rest of this course. Okay, you have to know this. So make sure you look at it. We're going to get tons of practice with it, but commit these ratios to memory.